But yeah, so here we have Jeffrey Steuer. Should have checked on that before. He's a retired professor, and he's here to talk about climate reality. So
thank you. I have to correct, I'm not a retired professor. I was a water engineer.
I really should have.
That's okay. Water engineer with the U.S. Geological Survey. And thanks for coming out. I'm going to do my best to make it worth your time. And well, let's see if things will move here. I guess I should have checked that also. So before I get into it a little bit about myself. So I am a retired water engineer, and I received the climate reality training about 3 years ago. And part of the training is to pay the information forward. So I'm not an expert. I'm a concerned citizen. But I'm also a fortunate grandfather. That's Jack, who's now 3 years old, and Ruth, who's 10 months. And you'll see more of them a little bit later. So a couple purposes. One is to pass along some ideas you maybe have not thought about. And then also, when I'm done, we'll have a discussion. I would like to learn from you also. I have a couple questions of you. So really 3 parts. Do we need to change? And then can we change? How would we change? And then actually, will we change? So this is a shot looking back at Earth from the moon. And to me, it just looks finite and beautiful. And just a little bit of science. So we receive heat, solar radiation from the sun. About 50% is absorbed by the Earth's surface. About 25% goes off to space. And about 25% is trapped in our atmosphere. And you hear about the greenhouse gases. And I'm going to be talking about carbon tonight. And we need that in the atmosphere. That makes Earth habitable. But what we've done since about World War II is we've put much more carbon in the atmosphere so that it's insulating much more than it did before. And we're really using the atmosphere as sort of a sewer. And the atmosphere really is thin. If you drive it at interstate speeds, you'd be through it in about 5 to 7 minutes. So it's not a real thick layer. And this carbon I'm talking about, where does it come from? Well, it's been underground for millions of years. I'm talking about the coal, oil, natural gas. And the top 3 uses of those fossil fuels is electrical generation, transportation, and industry. So on this graphic, you see how this is the amount of fossil fuels used globally, and you can see how it's really increased after about World War II. And you can see the little decrease there of COVID. And this graphic just shows that of that fossil fuel, about 1/3 is coal, about 1/3 is oil, and 1/3 is natural gas. Now, some of these slides I'm going to go through pretty quickly, but these next 2 I'm going to spend some time on because I think they're important. So this axis right here is time, going back in time. So back here about 11,000 years, that was the last ice age. About 6,000 years ago, we started to form villages and small cities. This axis is carbon dioxide in the atmosphere. And you can see over time that carbon dioxide naturally goes up and down. You can see it go up for a period where we have a lot of volcanoes, and it naturally goes down. It goes down when we have a lot of vegetation on Earth. Plants use carbon dioxide, so it goes down during those periods. But take a look over here, after about World War II, how it shoots up, how rapidly it shoots up, where we're currently at about 425 parts per million of CO2. So we bounced around since the Ice Age here from about 260 to 280 or so. Now I'm going to blow up this section right here, this 150 years, I'm going to blow that up. And if you notice the carbon dioxide goes from about 270 there up to 420. And it's going to be the red line on this graph. So if you take a look at this red line, and here's our carbon dioxide, it goes from about 280 up to 450. So I've blown up the last 150 years, since about the Civil War. But also on that graph, you see global temperature, the change. And the global temperature, it goes up and down. That's weather. But you see how it tracks the carbon dioxide. The pattern, that's climate. The pattern tracks it. Weather goes up and down, but the pattern tracks CO2. And that's because CO2 is an insulator. And you can do this experiment in your home. If you take 2 bottles, fill one with the air in this room, put carbon dioxide in the other bottle, put a thermometer or a thermistor in each one, put some heat lamps on, and the bottle that has the carbon dioxide, the CO2, heats up more rapid, and it holds its temperature higher. So it's an insulator. Does that make sense? That you saw that last graph how the temperature followed CO2. So what happens? Let me make sure I didn't skip a graphic here. Okay. So what happens when you have this extra heat being held in the atmosphere? Well, this is the temperature on Earth globally since the 1880s. If you took the average temperature, which years were cooler? These years were cooler. Which years were warmer? Those off here to the right. It's a pretty clear pattern. And I just want to see if I can point out this last. Here it is. This right here, this is 2023. And you can see that we're about 1.3 degrees Celsius above the industrial period. So just keep that number in mind, like 1.3. So when you have this extra heat, we've had record temperatures across the U.S. This is an example last year in California. And globally, in 2024, we had record temperatures globally 3 days in a row. And who's most vulnerable to the heat? It's the poor and the homeless, elderly, young people, pre-existing medical conditions, agriculture workers, folks who work outside. And this extra heat that we're trapping in the atmosphere, much of it goes to the ocean. 93% goes to the ocean. And one of the things about warmer water is you get stronger hurricanes, because hurricanes draw much of their energy from the heat in the water. So, well, before I get into that, so this is a similar graphic. This is ocean temperatures. And if you took the average ocean temperature, which years were cooler than the average? It's these here. The ones off to the right are the warmer temperatures, warmer than the average. So again, a pretty clear pattern. So I'd mentioned that hurricanes get a lot of their energy from the warmth in the ocean. So this is a graph of the temperature in the Gulf of Mexico. These are the months, and the average temperature is the gray. And you can see 2023. So this last year, this is the temperature in the Gulf of Mexico. So on September 26th, we were quite warm compared to historical temperatures. And that's when Hurricane Helene hit, very large hurricane. And this is the one that went up and dropped all the water up in the Carolinas. So this is a shot of some of the flood damage in the Carolinas. Infrastructure damage from intense storms like this. Tremendous flooding from that much water. And Helene dropped about the same amount of water that flows over Niagara Falls in over 600 days. It was a huge amount of water that came out of that hurricane. So then about 10 days later, so let's go down here, we're still substantially warmer than the 10-year average in the Gulf of Mexico. And Milton hit to Florida, and I had a Coast Guard friend who's lost everything in that event. And at the same time, there was a hurricane forming in the Pacific side of Mexico. So a year ago, or a year and a half ago, it was the first time on record that in all the basins around the world, whether it's Pacific basins, Australian, Indian Oceans, Atlantic, you've had these Category 5 storms that developed. And one of the things that results when hurricanes oftentimes is, you have the refinery areas, you have the industrial areas with toxic chemical releases. And oftentimes that's the poorer folks that are subjected to, living in these areas. So as this warmer temperature takes more water from the oceans, it takes more from the oceans. You end up with a lot of water vapor in the air, and you end up with atmospheric rivers. The weather folks are referring to these atmospheric rivers. This is a shot of that NOAA had of one off the coast of California. So when you have intense water like that, you have these intense rainstorms. And the reason for that is for each 1 degree C, so about 1.7 degrees Fahrenheit, if it's warmer, it can hold more water. In fact, it can hold about 7% more water. So the warmer the air is, the more water you can hold. So right now, there's about 5 to 15% more water in our atmosphere than there was 50 years ago. So the downpours get bigger, so that some of these atmospheric rivers carry as much water as 27 Mississippi rivers. So you end up with intense rainstorms. This is some flooding in California, but it's also overseas. This is flooding in Poland last year that took the lives of 24 people. And here in the Midwest, this is Iowa. And the more intense precipitation events are becoming more frequent and intense. You can see here in the Midwest, they've increased by about 45%. And I had a temporary assignment in the USGS to measure floodwaters on the Red River. And so we were measuring the amount of water going under and around bridges. And it was, I remember seeing a farm that the only thing I could see of the farm was a little tip of the barn sticking up. The rest was flooded. So it affects, flooding affects farming. So this extreme weather affects our infrastructure. I'm not going to go into all of it, but the Wall Street Journal is writing about how this extreme weather is hitting us in the pocketbook. And last 7 years, it cost us in the U.S. $1 trillion. Well, $1 trillion doesn't mean anything to me. But if you divide it by the amount of 18-year-olds and above we have in this country, it comes out to be about $27,000 a person is what it costs us in the last 7 years. So this extreme weather is costing us money. And this same heat that pulls more water from the ocean, it also pulls it from the land. So we're ending up with longer and deeper droughts. This is just a map of the drought conditions in the U.S. Last year. The red are the areas where the droughts were the strongest. In the southwest U.S., the last 2 decades have been the driest in over 1,000 years. And it's overseas also. This is a drought in China. Hang with me. I mean, listening to all of this stuff is not easy, but it's going to get better. We've got solutions, but I've got a few more minutes of the effects yet. So one of the things that happens when you have warmer temperatures, you have more fires, and the reason is, and this scientists have relatively recently determined this, that for every 1 degree, so 1.7 Fahrenheit, you get 10% or more lightning strikes. So warmer atmosphere, you get more lightning strikes, you get more lightning strikes, you get more fires. So Oregon had a lot of fires, and extreme wildfire events around the world more than doubled in the past 10 years. Something I experienced firsthand. These were Canadian fires in 2024, and the smoke made it down this way. So this is a shot. I live close to Lake Monona, where you can see the Capitol. And notice on the right-hand section here, these kayaks and canoes, right? So this is a typical summer day, a picture taken, and this was the day, about 2 days after, where we had the wildfires in Canada. So notice the canoes here too. So looking across there, it was a beautiful sunny day, but you could not see across because of the smoke. And I was breathing okay, but you know, it was shown to be dangerous air quality out there. And Amy said, "Man, you should wear a mask." And I said, "I'm feeling okay, you know." But within like 2 days, I read an article that, and it's recent research, that smoke from wildfires, the farther you are from it, so in other words, the longer it's exposed to the sun, it changes so that it's more dangerous to your cells. So not just your lungs, but the smoke particulate, the smoke molecules, I should say, can enter your tissues more readily after they've been exposed to the sun. So the farther you are from the smoke, the easier it is and the more toxic it is for your cells. I was wearing a mask. So I have this shot in because you've got folks playing golf, and you get these fires in the background, and we can't allow this to be acceptable, to be normal. So we've changed the hydrologic cycle. We've changed the evaporation rates, and we've changed precipitation, how that occurs. We've changed the hydrologic cycle. The Department of Defense has said that the climate change is going to cause pandemic disease and refugees. And globally right now, in 23, there were a lot of people displaced by extreme weather. And this is a shot of Syrian refugees in Croatia in 2015. And I was in Croatia in 2015. I was on a train. It was about 1/2 of the situation with refugees storming the train. The police had it under control. And at the time, I thought it was the political situation in Syria. That was the whole reason. But it turns out they've had a strong drought where they lost over 50% of their farms and had to lose a lot of the livestock. So it's the refugee situation I experienced was due to a number of factors. So a little bit about the snowpack glaciers. So this is Greenland back in 1935, and here in 2013, the glaciers are just about all gone, and the ice mass, if you look down here to the right, has continued to decrease down to 2023. I have this shot in because to remind me, so I was in a mountain village in Peru where the local farmers depended on the snowmelt from snowpack to irrigate their crops. And normally melt in the summer, it would regenerate in the winter. It wasn't regenerating where they were just about out of water, and they didn't have an alternative. They had no mechanical ways to do it. So it affects people around the world in different ways. This shows the ice pack at the North Pole. You can see how it's diminished. The Antarctic ice mass has also decreased. I have these shots in. I was on a Coast Guard icebreaker buoy tender for a couple of years, and it was a steel-hulled vessel, extremely noisy going through the ice. So we shut the engines off and we let the crew pull the vessel for a while. No, I'm kidding. We're just, obviously they're not pulling the ship. We just got on the ice and horsed around. But I have these in here because you need ice at the poles for the ecosystem and wildlife, but also ice is just plain beautiful. This is some pancake ice near the Sturgeon Bay Ship Canal. So as ice melts, ocean levels will be rising. So this is the top cities globally at risk, and you can say Miami and New York are right there. And if we get to a constant 2 degrees C, about the rise, it's estimated 12 million people in the U.S. will lose their homes to sea level rise. And you remember, we're at like 1.3 C here last year. And overseas, I mean, Kiribati is a South Pacific nation that's had to purchase land because the rising sea levels, they've had to move some of their citizens. So the Pope has stated that the toughest effects of attacks on the environment are suffered by folks who have the least ability to afford to do something about it. A touch more science. So heat on Earth here is transferred from the equator to the poles, and that sets up the air currents and the ocean currents. When I was in the Coast Guard in Miami, you have the Gulf Stream that goes by. We would count on that in search and rescue cases, but the Gulf Stream and these patterns really dictate temperatures in Europe and around the globe. They're important. And scientists are uncertain as to what point these patterns will change. So there's not agreement as to how soon that will happen, but there is concern that we're getting close. Medical journal Lancet has said that the climate situation is a large global health threat here this century. I'm not going to talk about all of these. We talked a little bit about extreme events and heat stress. I am going to talk about air pollution just a little bit. So due to particulate from fossil fuels, whether it's automobiles, whether it's from coal plants, about 8 to 9 million people die around the globe annually. And I had no idea that here in the U.S., for the 20 years from 1999 to 2020, that just about 500,000 people, we had early deaths due to coal particulate, and it's globally also. And one thing about coal plants, it's kind of a triple whammy, because it takes carbon, coal that's been underground for millions of years, and it puts it up in the atmosphere. It also has air particulate that even with scrubbers gets up in the atmosphere and damages our health. But it also takes mercury, which is on the coal, and when it's burnt, the mercury goes up into the atmosphere, and then it's deposited with rain down into our lakes, our rivers, our streams. I had a colleague at USGS, Dr. Krabanoff, with his group that spent a career researching how mercury is deposited down and how it's tracked through the systems here on Earth. So I think, and most of us realize that women of childbearing age and children need to be aware of the fish they're eating because of mercury. So that's the cost of carbon, and it's high, and it's a cost that I don't want to pass on to Jack and Ruth. And Earth is a complicated system, but it helps for me to think about how carbon, whether it's carbon dioxide or methane is CH4, but carbon we're putting up there is an insulator. That principle is fairly easy to understand. So do we need to change? We do. And here's the good news. We're not doomed. We've got the solutions at hand. I mean, it used to be felt that if we leveled off the carbon we're putting up in the atmosphere, it would take 25 to 30 years for things to get better. It was going to keep going. But that's not true. Recent research over the last few years has shown that if we can level off what we're putting in the atmosphere, within as little as 3 years, we can stop this, what's going on. And that's because the oceans can actually store or sequester more carbon than science thought a while back, and also the global vegetation. So right now, we've got the solutions, and I'm going to talk about a chunk of these, to reduce emissions by 50% within 5 years. So how are we going to do it? Well, one way is wind. I mean, it was felt back in the year 2000 that we would increase wind capacity by about 30 gigawatts in 10 years. Well, in 20 years, we exceeded that by a factor of over 30 times. So the cost of wind, producing wind, has really come down over the last 40 years. And in Germany right now, they produce over half of their electricity as of a few years ago from renewables, from the wind and solar. And wind could produce worldwide electricity 40 times over. Solar panels, I think we're all aware of solar panels. And solar panels have really gone down in cost. I mean, here you see now it's like 11 cents a watt. We're up here in the 70s, we were talking almost $80 a watt. So they've really come down in price. So that we had a solar project installed about every 40 seconds in the US a year ago. And it's overseas also. I mean, Australia, about 1 in 5 houses have solar panels. And the Vatican is the first sovereign country to be net zero with carbon. Here's a shot of all their panels. Of course, they're a pretty small country. And solar panels work well here in Wisconsin. I have them on our house, and if you want to talk about that afterwards, I'd be happy to talk about my experience with the solar panels here. And this is a shot of solar and agriculture. You see sheep grazing under the panels. You see a livestock shed with panels on. You see crops being grown. And the University of Wisconsin is doing research as far as crop growing among panels. And there's a shot in a transportation setting where you see solar panels between the transportation lanes. And there's a lot of sun. If you took all of the global energy need for a year, it's delivered to us every hour. That's how much solar we have. So the amount of energy the world needs for a year is delivered every hour. But the sun doesn't always shine. The wind doesn't always blow. So you have to store this stuff. And this is a graph by Bloomberg Finance that just shows how this is where we are in 2024, our storage right now capacity. And this is the storage capacity they are projecting globally here within 25 years. This is a battery storage, energy storage installation in Texas. The university here is partnering with a power company to store energy with compressed gas. So when they have extra solar or extra wind, they take that extra power and they compress gas, and then when they need the power, they generate from the compressed gas. They're also looking at thermal storage like Salter Stand or liquid hydrogen. I'll talk about that a little bit later. And I'll talk about batteries a little bit later, but the UW is also researching alternatives to the lithium batteries. They're looking at sodium, and there are some researchers that are looking at silicon batteries, silicon being from sand. There were a couple of things in the training that really surprised me that I just hadn't thought about or wasn't aware of. And one of them is this graph. This is the amount of money it costs to produce electricity from coal. And you can see it's pretty steady with time. To produce electricity from natural gas is cheaper. And you hear natural gas being advertised as the clean alternative. And that's true partially because natural gas doesn't put particulate up in the air, doesn't put mercury up in the air. but it's still taking carbon that's been down there for millions of years and putting it up in the atmosphere. So it's not a solution. The cost of electricity from nuclear has gone up a little bit for a couple of reasons. The cost of electricity from wind has gone down, and the cost of electricity from panels has really come down, so that if you're a power company and you need to add on 25% more power, it's just cheaper right now for you to do it with wind and solar. Here's a CEO just saying that coal plants are not economical, and that was as of a couple of years ago. Now, the coal miners didn't bring this on. We have to keep them in mind, but they certainly can be retrained in renewable energy fields, and it's going to be a safer job. I mean, the Massey coal mine accident some years back cost the lives of 29 miners here in the US. And right now, there are 10 times as many jobs in solar and wind as there is in coal mining. I have this shot in to remind me to mention about the Deepwater Horizon spill. My son was in the Coast Guard and was stationed down there for about 2 months during the spill, and just him talking about how difficult it was to try to contain the 3 million barrels of oil, and also the lives that took. That took 11 lives when the platform blew up. So getting off of fossil fuels and getting to renewable energy is going to be safer for the planet and for humans. So there are a lot of clean energy jobs in the US right now, and it's growing twice as fast as the overall economy. And I'm from Manitowoc, and I think Manitowoc is making the columns for these wind turbines. And it's overseas. China has put in more solar than US and Australia combined. Another thing I hadn't thought about in the training was this, that folks around the globe who haven't had power, they haven't had a stable government, they haven't had a power company that could get it to them, they're going to have power. Because it's easy to put up a solar panel and a battery, and now you've got power for your refrigerator, for your water, for your lights, for your computer. This is a shot of just some portable panels for computers. So a lot of companies have committed to go renewable. These are the logos of many of them. And auto manufacturers are moving to electric cars. And GM has said they're going to phase out the gas and diesel passenger vehicles in 10 years. Volvo, within 5 years, all their vehicles are going to be electric. And, you know, in this country, it took us about 20 years to go from horse transportation to cars. That's how long it. And think about what a change that was. I haven't researched it, but you know, it disrupted the folks in business that had stables for the horses and overnight stays. But you had to put in the roads and the stations. But we did that in 20 years. So you know, we can do this. And as far as batteries, you know, research facilities are looking at solid-state batteries, which will charge in minutes. And Honda's looking to use them here in 5 years. And the charging stations around the US, especially after the Inflation Reduction Act has really kicked off. And as far as moving freight, you know, Tesla is looking at trucks. Around the globe, countries are looking at phasing out combustion engines. California up there is looking to phase it out here in 10 years. If you look at Norway, they have just about completed their phase out. This is from an article in a year ago that they have just about phased out combustion engines, and you know, their air of their capital, Oslo, is noticeably cleaner. They didn't have a big problem with unemployment at gas stations or auto mechanics, and it didn't strain their electrical grid. So Norway's a lot smaller than we are, but we can still learn from some of these efforts from overseas. So a couple of additional solutions, and then I'll wrap up. One is, I don't know if any folks here are involved in farming, or you've got relatives that are in farming, but farming is going to be a huge part. There's not going to be one thing that is going to get us off of fossil fuels. There's going to be numerous different approaches. And agriculture is a big one. You know, the crop rotation, no-till, cover crops, rotational grazing. I don't know that much about regenerative, but all of those approaches keep vegetation on the soil longer. And if you think about it, the more you can keep vegetation in the soil, plants use carbon dioxide, right? So the longer we can keep plants on the soil, and it's better for the soil health. This is a steel mill in Sweden that's been making steel since the 1600s. And they use something called green hydrogen for their heat rather than coke or coal. So what's green hydrogen? If you take electricity from a wind turbine or solar or hydro, and you take that electricity and you apply it to water, to H2O, electrolysis. H2O, it splits off the hydrogen and the oxygen. You capture the hydrogen, and that hydrogen can be used then in industrial processes. So it comes from water. That same hydrogen that you have kept can be used to run a car. That's what a fuel cell is. So it's a way also, it's a great way for industry, but it's a way of storing energy too. And Sweden now uses literally a tenth less carbon to produce their electricity than the rest of the world. Their economy has expanded 50%, you know, and they have healthier air. Another thing I hadn't thought about was kind of the big picture. So the agricultural revolution, where we went from hunter-gatherers to growing our food, took about 700 or 800 years. It took a while. The industrial, where we went to power-driven machines, that took about 80 years. The digital, computers and cell phones, that's happened during my lifetime. It's been very quick. So it's felt that the sustainable economy, the clean economy, can happen very quickly because it's built on these other movements. So can we change? We can. And for me, one of the things that gives me optimism is just how cheap it is. Just from our free enterprise system, it's cheaper right now to produce electricity. So will we change? Well, we got back into the Paris Agreement. What the future will hold, I'm not sure. The Inflation Reduction Act added 100,000 new American jobs. And it's overseas also. I mean, Australia, Brazil, the European Union all have passed laws and legislation moving in this direction. And here in Wisconsin, we've, this is a little bit dated. This is April of 22, but since we've had a clean energy plan, we've added 73,000 clean energy jobs. Much of it is in rural communities, and it's across the political spectrum. Of the 11 projects, 9 of them are in Republican-held districts. So it's happening in Wisconsin also. And local municipalities are looking to be renewable, and some of the municipalities around the states have achieved it. But you can tell we need to do this fairly quickly. And have we ever done anything quickly like that? Well, AT&T back in 1980 said, how many cell phones are we going to have over the next 20 years? And they said, well, maybe about 1 million. Well, they missed it by a factor of 100 because there were 100 million. And now they missed it by another factor of 100 because there's 10 billion. So they weren't just wrong. They were really wrong. So why were they so wrong? Well, the cost of a cell phone dropped sharply. The cost of solar panels are dropping. The quality of cell phones improved dramatically. The efficiency of solar panels are improving dramatically. And here's a fairly big one. The low-income nations that didn't have the ability to put in phone lines, they don't need the phone lines. Same thing with solar panels. You know, where you had these messes, you know, you don't have that. Well, this is a graphic showing The amount of cell phones from 1990 for the next 30 years, that's in the developed world, and this is the undeveloped world. And it's felt that solar panels and renewable energy can be similar because it doesn't take a stable government, a power company, a lot of money up front to make it happen. You have a panel and you've got a battery. So this is a shot of some panels in South Africa. So Time magazine called 2022 kind of the year that people and organizations, governments came together. We had electric vehicles. We had the offshore wind power took off in Europe, and the US started it. Some carbon sequestration. Batteries were really breaking through. Coal plants were not being used. But this one here, linking cause and effect, where scientists are really starting to understand what's going on with the climate, so that they're just not saying that here's the temperature trend. They're able to understand the chemistry and the physics so that they can say, if we go to 1.5 degrees, this part of the world is going to be drier. This one may have more intense rain. So they have a much better understanding. They're not perfect, but a much better understanding. So a couple months ago, I was listening to a news story in my car about the drought in Morocco, and I was curious. I thought, well, these predictions that were made by the International Panel on Climate Change, made in 2021, does that match? And this is from, if we rise to 1.5, we're just about there, their prediction for droughts across the globe. So the darkest brown is the heaviest droughts. And Morocco is right there. So it matches what their calculations showed. I'm not going to take time of going into looking at it from a point of view of risk, but people are starting to come together. I went to Paul Ryan, the ex-Speaker of the House, Republican Speaker of the House. He spoke at the university here a year and a half ago, and I went to listen, and these are his words. He had said, I think decarbonizing is the right thing to do. So let me just say it for the record. It's good to get carbon out of the atmosphere. Now, he didn't agree with exactly how the Inflation Reduction Act did it. He had some other ideas. But people are coming together on this. And young people around the world and here in the States, they want a planet that is going to be safer for them and their children. So we're at a decision point. We've got the ugliness I was talking about in the first half, with extreme weather events and all of that. But we have the solutions. We can choose to correct the climate, and we're going to correct a number of other things also. I think if we correct the climate, we can have, I think, a better planet than we've had since about World War II in many ways. But there's going to be resistance. We don't like change. Most of us don't like change. And there are interests, oil and gas interests, that don't want change. In some ways, I won't go into it here, there's some parallels between some of the stuff the tobacco companies put out and some. So, beyond the climate, we can have a renewable economy that has got abundant clean energy, safer for the planet and people. We're not going to have oil spills, platform explosions. We're going to have bluer skies. We can choose to correct the climate. And in many ways, it's an opportunity, and it's not a sacrifice. I'm going to ask you to do three things, though. One is with your choices. In other words, we all can't have solar panels on our house right now. We all can't have an electric vehicle. We all can't maybe have a heat pump. But if you don't need to idle your car or your truck, don't idle it. Insulation is an important thing. The food we choose, eat one less meal of meat every 2 months. Reuse things. Your vote. I'm not going to ask you to vote Republican, Democrat, Libertarian, but if you're at a primary and one of the candidates is talking about what we're putting in the atmosphere, consider it. And then use your voice. And this isn't easy, but talk to your family, your friends, your neighbors. I'm not asking you to convince them of anything, but just see what they're thinking. It's important because, Lincoln said, public sentiment is everything. And our children's world, depends on it. So my motivation it's my wife Amy here and our 3 adult children. My motivation for doing this really is twofold. One is, I think, so that's Beth and Jack and Ruthie on the right, and I think it's extremely important for them, their future. But also, and we're gonna open it up for questions here. But I would like to know from you if there is, and I'm gonna send these out with my email address and a couple of slides that I think are important if you just pass them around. But one of my questions to you is, after hearing this tonight, and just what you know in your own life, talking to neighbors and friends, if you don't realize we've done something to the atmosphere and we need to do something about it, what is it that would cause you to realize we did? In other words, do you need to see the oceans rise 4 feet? Or do you need to see the temperature in Dane County be 110 for the month of May? What is it that would cause you to say, hey, we've done something and we need to do something about it? So also on that sheet, I have the Project Drawdown is a great organization. They are independent scientists that have produced details on solutions that we can do in our everyday life, but also that we can do in our jobs. So, if you want to spend some time, look at the Project Drawdown South site and their table of solutions. So with that, I'm just deciding now whether you guys are, you got 3 more minutes in you on. I would play this little clip. Are you okay with 3 more minutes before we, because to me, you got me, a concerned citizen, talking about this stuff, but here are what experts have said. Where'd my screen go? What experts have said a world would be like. I'm not sure what I got going here. Well, but I don't show it on my screen either. So I'm not sure. Anyway, let me just see here.
Was computer
So,
shut off?
Well, unless it's, since it's not displaying on there, it's not here. But anyway, let me just see if this actually kicks in. I'll play the 3 minutes because it's basically 3. I think we're good here. It's 3 minutes of, maybe we're not going to get it. 3 minutes of folks, of experts saying what the world will be like once we make this change. So anyway, pardon?
What's the name of it was a TED Talk, right?
It was a TED Talk. And I tell you what, if you're interested, oh, you know what it is. Yeah. All right. I'll tell you what.
Let's answer a couple questions.
Yeah, for sure. That's the deal. Okay. Let me kick it in. So one of the things I would like to know is there something that you're aware of? Is there something I'm missing? Or anyway, thoughts, sir. Got any?
I just want to invite anyone here, if you live in the village of Oregon, we have a sustainability committee that just started last year. We are trying to reduce emissions in the village and get people involved, and there's a whole plan that people have put together. We meet every 3rd Wednesday of the month, and from 5 to 6, 6:30. Everyone's welcome. come listen, come join. Like let's make some change together.
On the village website.
It's on the village website. Yeah.
Would you take someone from the town of Warren?
Absolutely, yeah. I mean, from anywhere. You
Because
can
I'm not
live
in
in
the village.
Middleton.
I'm close to the village, but
Yeah.
I'm not in the village.
All welcome. Yeah.
If I guess a couple things also. If you guys, I'm going to do this for another 6 months anyway. And if you know of any other groups, if 3 people that I could pass along this training to, I would love to. And if any of you want to take the climate reality training, they've trained about 50,000 people around the globe in over 120 countries, and there's no charge. It's a 4-day training. Normally, I took it during COVID, so it was remote. Normally, you travel to a city and it's on your own dime, but there is no cost. And they asked that for the first, I took it about 3 years ago. They asked for the first 6 months you pay the information forward, meaning not too many in our chapter go out and speak, but all right. Let me see if this works here. You know what? Let me make sure that I'm logged in here to the library here. I think so. So not getting much response on that. Let me just see if I can pull up another page here for kicks. Looks like it. Okay. So I'm going to try this. Let's see, we go. Hopefully, these 4 minutes of experts talking will be worth the contortions here. Grinding away, but we'll see what happens. Any other? Yes?
Just one question. It feels like, at least to me, I'm in my 20s, that every 4 years there's a push and pull of moving forward and then dragging us back. Every 4 to 8 years, depending on how the president feels about environmental matters.
Right.
How can we in local communities, do you find that it's easy to make change in local communities and that tends to have most impact? I know, like, obviously the Paris Climate Accords, we've pulled out, we've gone in, we'll probably
Right.
pull out again.
Right.
How can we kind of like not despair every
Right.
so often when things change?
You know, I am probably less knowledgeable than a number of folks in this room as far as the effects on what local government and state can do. But you know, I've read, trying to think where the article was. It might have been in the Wall Street Journal. That yeah, even if the feds don't push as much, state-wise and local-wise, there's still a lot that can be done. It's going to be tough to turn back. But you know, in many ways, it's you know, well, in some ways, you know, we're an example to the rest of the world, right? And to have the federal government not be going in that direction is hurts. But I don't have any expertise there to help you out there. But I've read a couple. I'm just going to try and pull this this address again for this website one last time. It's buried down in this one here. That in some ways we might be far along enough that it's going to be tough to turn it back because the Inflation Reduction Act has added a lot of jobs, and it's you know.
I mean, it seems like from what you said, like the cost is hard to beat, and I think that alone gives me a little bit of hope.
Yeah, exactly. Let me try this one last time here.
Do small changes locally.
Yeah.
Enter.
We'll see if this. Okay, watch this. Might be kind of loud here for a sec here.
There's no doubt that we are facing exponential impacts.
All right,
of
so
climate
now
change.
let me,
There's also, however, no doubt that that is being met.
just want you to listen to the last.
A lot of ideas, a lot of stories, and a lot of big plans. So we want to wrap things up by asking our experts, what if we actually achieved our climate goals? What would that future even look like? They, of course, had a lot of thoughts. We'll let you pick your favorites. Thanks for watching.
If we are successful in addressing the climate crisis, we massively reduce the vulnerability and improve the economic and the creative prospects of billions of people around the world who currently are basically excluded from all the opportunities which we have, which come from having abundant material and energy all around us. That's the real prize.
A world where we have had that exponential would be a world in which we have clean, cheap energy for all.
At the end of this decade, the International Energy Agency believes that we will have enough capacity to be producing 10 billion batteries a year. It's enough for every person on the planet to have their own battery.
I'm constantly surrounded by young people, just like me, who are really, really, really passionate about the world that we live in for obvious reasons. It's the world that we will inherit.
Women are very important for the energy transition. So if we're talking about a world where we have, where we tackle climate change, all I want to see is, women in power. I want to see more solutions being driven by young people. And I want our politicians to be truly and meaningfully engaged in making change.
We always tend to underestimate the pace of ultimate adoption and change. Today there are more than 150 pathways, scientific pathways, that we could take to limit global warming.
If we get to true net zero, astonishingly, global temperatures will stop going up with a lag time of as little as 3 to 5 years.
We've been able to accelerate tree growth and carbon capture in tree stems by 30 to 70%.
Offshore wind has the potential to cover the current electricity demand of the entire world, not once, not twice, 18 times.
We need to decarbonize the old economy that we have and invest to create the new economy that we need.
Regenerative farming is fairly simple in concept. It means creating the conditions for more life.
We need to buy less stuff, and we need to look after what we buy. Valuing the things that we own is a climate solution.
We can all live in this transit-rich, carbon-negative, affordable way and leave the vast majority of the planet for nature, for agriculture, for clean oceans. We can do this.
The ocean is a powerful source of solutions that we've overlooked for far too long.
You have to be engaged. Let your elected officials know that this is important to you. You have to vote, you have to go out there and support politicians who are going to support our planet.
We can create a legacy of environmental quality and climate resilience for all.
You are not powerless. That there's nothing we can't do. Just keep going. It's symptom, not cure. But you are needed.
The power of what we can do when it matters to us is unlimited.
It's not that we're simply going to avoid the worst impacts of climate change. It's that we're going to improve the quality of life for humans, both in the urban and in the rural sector, and for non-humans.
All right, well, thanks for coming, and if you know of any group, like I say, I'll come for 3 people. Just let me know. Contact and so any other questions? So.
I notice I hear a lot of people say that they get daunted when you say at 1.2 with a very nice climate, with a centigrade. I don't know if people are really understanding that.
So your question is whether they understand what if you talk about centigrade or Fahrenheit. Yeah, that's true. It's scientists and engineers typically talk in centigrade, and we here in the States we use Fahrenheit. The rest of the world pretty much uses Celsius or centigrade. But that's a good point, and I will. All I can do in my little corner, I guess, is try and make it clear. I try and.
Because if it's broke down into layman's language, people might be able to absorb it better.
Yeah, and with what you just said there, I have one or two slides there where I talk about 1 degree C, and I verbally say that's like 1.7 Fahrenheit. I should change that slide to, that's a good thought. Yeah, thanks.
I think too, like on that note, it sounds less severe when we say 1 degree Celsius.
That's true, yeah.
Right there.
Yeah.
I've gotten input from people, they say, it's only 1 degree in a certain amount of time.
Yeah. Well, and I didn't mention it, and I have it in my notes, but I think the Ice Age was caused from a variation of only like 4 to 7 degrees Celsius. So in other words, it wasn't 20 degrees, or so 4 degrees Celsius, we're talking maybe like 7 Fahrenheit or something like that, that caused the Ice Age. So we're not talking about 20 or 30 degrees causing these changes, so I was, I use that example when I was in the car and I was listening to that drought story on Wisconsin Public Radio on the Morocco, and I thought, does that match with what the modelers were saying? And went and looked up the report, and sure enough, at 1.5, and when you look at that map for like the U.S., at 1 point, because it's a global map, and the scale, if you looked at that map, I can bring it up if you want, the scale is fairly rough, but it showed drought in the southwest of the U.S., and so anyway, they understand. I didn't get into the risk. So the science has been criticized sometimes for not knowing it exactly, that the scientists don't have it right on the money, but they're getting so much better. And then I thought, if I live downstream of a dam and there was a 1 in a billion chance of this crack opening up and wiping out my house, I wouldn't move. But if there was a 1 in chance, 1 in 10 chance, a 1 in 5 chance that crack was going to fail, I'd move. And it wouldn't matter whether the engineer telling me that this crack, the dam may fail in a 1 in 5, or I might be off by a factor of 10 and it's 1 in 50. I'm still going to move. So even though the science hasn't nailed it right on the money, I think the analysis should be, terrorism looks at, the insurance industry looks at kind of risk assessments. Why we don't see more of that in the discussion? Look at it at the, which is, there's been I read a book that dealt with it, part of it, but so essentially, just as a general thought of looking at kind of a bad case scenario and what's the chance of that, and do I want to live with that chance, so.
Before we came to I was searching online on climate change, and then one of the excerpts that I did read, they said that nothing is instituted or correctly getting things moving that it could have, we could run out of time within 12 years.
Okay, and did you hear what he had said? That we may have, yeah, I don't know about that, but what I am personally very confident about is we need to move. Yeah, we need to move. But also, this Project Drawdown, if you have a chance, go to that website, because they really do. They're a really sharp group, and when you get information, one of the things you need to consider is what's the motivation of that person giving the information. That's not everything, but what is their motivation? What's their background? Have they in the past produced reputable results? That kind of stuff. And Project Drawdown is a really good group, and they are saying we can still do this, but we.
What I was really shocked by, was interesting, is the amount of things that climate change hit. I mean, everything.
Yeah. It is, and it does. We talked about the water cycle, but it also the particulate as far as pollution. I didn't get into the disease. I mean, there are more ticks now in Wisconsin due to the temperature. It changes mosquitoes, things like that. But if we solve the fossil fuel situation, I touched on we can improve the life in the planet in so many ways. I mean, I had heard a talk by a researcher out in California. He was a professor with there was actually a group of them, and it was his position. He kind of looked at future economic scenarios of the globe, and he was saying that he was assessing that in the future, energy will be so cheap in the globe it will almost be free. That if we move to renewable energy, So we've got. I said it in the one slide. In many ways, the way I look at it, it is an opportunity, not necessarily a sacrifice. Now, granted, there are going to be some people that it doesn't work out quite as well for, but that's our system. You adjust, right? I mean, same thing with the horses to the car. The person that ran the stable to hold the horses overnight he had to adapt, and the fossil industry fossil fuel is going to have to adapt, and they see it coming, and I don't have a chance to talk about it, but the Climate Reality also talks about they're moving to plastics, right? They see that one of the next major uses of oil is plastics. Anyway, so there will be resistance by certain groups, but also we're not super comfortable with change. That's just people.
Back in my prior life, I've worked with change management, and that's always the problem, is how do you get people to change? And when there's a drastic event, people change very quickly. Well, here it's like the frog.
1,000 cuts, right?
In the pot of water, just a little warmer, a little warmer, a little warmer. They don't do anything.
Yeah, I'm really encouraged in Oregon. This building has solar panels. We have geothermal heat and cooling. So that was a big investment that the village put into this building. And at one point it was like, well, we're over budget. We can't do this if we cut geothermal. And the village was like, no, we're doing this. And they actually put in more money. So I have goosebumps thinking about it. It was a very amazing moment where I was like, wow, it's really gonna happen. So as far as locally, I'm very encouraged by that.
Actually, I've read some about it. How did geothermal actually work?
I don't know. Let me find you a book for that.
I can give you a quick shot at it. So the way geothermal works is, if you take your air conditioning unit, so essentially what it does, and I'm trying to explain this properly, but it's pumping a fluid through your house, right? So it takes that fluid and let's say it'll take it outside, and for an air conditioner, it will make it, squeeze it down and make it really hot. So let's just say, I'm going to make up a number now, but it makes it 1,000 degrees. So even if it's 100 degrees outside, that 100 degrees is cooling this 1,000 degrees. So even if it's 100 outside, it's going to cool that 1,000. Now it comes back in the house, it expands it out, and it cools. So it does it through compression. So in other words, that's how the air conditioner works. It will take it outside, squeeze it down really hot. Even if it's 100 degrees out, it cools it, brings it in the house, it expands it out, and it cools it down. A heat pump is the opposite. So, and geothermal, I'll get to what geothermal is. A heat pump is just the opposite, so that when it goes outside, rather than squeezing it, making it hot, it expands it, makes it really cold. So even if it's 30 degrees, I'm making up a number now, it's minus 100 in that tube. So even at 30 degrees, it's warming it up, brings it back in the house, now it squeezes it and warms it up. That's a heat pump. A heat pump uses the air. Geothermal is the same as a heat pump, but instead of using the air out there, it's using the ground. And the ground is always, at 40 degrees or so, something like that. So that's the only difference with a heat pump versus geothermal, is rather than getting that difference of what's in that tube either squeezed down or expanded in the air, it's in the ground, and it's using the constant temperature of the ground. That's what geothermal is.
I've read something about some people when they build a house, they'll build it underground. They don't really have to use much heat because it's they pretty much at a certain degree.
Yeah, so I don't know if you heard it about, yeah, it makes sense to me that, if you have, it's like super insulation, right? Because essentially you have the ground insulating. And Project Drawdown, they'll talk about in their table of solutions, I don't know if there's like 120 or something, and they talk about how important each one is in making this change. Some are more important than others, and insulation is, that's something we can do right now. We don't have to wait 5 years for it or anything, but yeah, it's kind of like super insulation.
Well, I want to thank you all for coming tonight, and I want to thank Jeffrey for the presentation. I really enjoyed this, and I hope you did too. So thank you so much, Jeffrey.
Yeah, my pleasure. If you know of any other groups, you've got my email, or if you have any thoughts, and if it comes to you and you say, Jeff, you totally missed the boat on this one. You should be thinking about this. Email me.
Thank you.
Yeah, thank you for coming.